All right. Hello, everybody. Just testing if things are working. Hi there, Chipotle. How are you? I see a bunch of people in the chat saying hello, so I'm going to assume that our live stream is off to a good start, but please let me know if there's any issue on your end. Hi there, everybody. And yeah, so how is Global Hack Week going for everybody? Any favorite streams so far? Yeah, so some folks saying good, cool. Yeah, that's awesome. I'm glad it's going well and you're enjoying it. Yeah, I think I was able to catch a little bit of Cecilia's stream and some streams from day one, two. So yeah. And Tanmay says, should I take notes or something for this workshop? You actually don't need to. It's going to be recorded, so there's no need to take any notes. Hi there, Control V. Good to see you. Hope you're enjoying the Global Hack Week. Yeah. All right. So why don't we go ahead and begin? We're going to cover a little bit of machine learning content today. And in particular, we're going to be implementing a classification algorithm. So this workshop is going to get into all the details on that. So why don't we go ahead and begin? But before we do, I wanted to make sure that everybody gets a chance to check in. So let me paste the link for check-in. Let's see if I can find that. All right, there it is. So go ahead and check in for this workshop. It's really important that you do. And yeah, all right. Oops, I'm actually going to upload those slides. Sometimes I forget that you can upload slides to this platform we have for streaming, and it makes it so much easier to share them with all of you. So let me try and do that. All right, here it is. So, my name is Steven, for those of you who don't know me. I've been a coach at Major League Hacking for more than 5 years now, and we've been doing Global Hack Week ever since, well, since 2020, frankly. So it's going to be now 4 years of Global Hack Week, and super excited to be here with you all. But first, I want to have us complete a quick survey, and this survey is going to help us learn a little bit more about you and get started. And Sandra says, can you share the slides? Absolutely. Thanks for reminding me about that. Let me share them with you right now so that you have them. So here's the slides. Just posted them if you want to follow along. And I'd love to get you all to fill out this quick survey. It's really designed to just get to know you better and yeah, learn more. Sorry about that, everybody. Um, awesome. So let's go ahead and look at the results of this survey. I pull that up right now. Looks like we got at least a few responses. Oh, 12. Awesome. So let's check them out. First question I had for all of you was, have you heard of machine learning? And oh my goodness, 92% of you said yes. That does not surprise me. It's super common to have heard of machine learning. But then this response is the opposite. So, have you built anything with MATLAB before? And most of you said no. Well, MATLAB is a great programming language and infrastructure for building code. Alberto is actually doing some MATLAB code. And so we are going to be paddling on that to do some classification algorithms. And here's another question. Have you trained a machine learning model? About 50% of you said yes, but actually the majority of you said no. So it's great. We're gonna all change that by the end of this workshop. That's awesome. Are there things about machine learning that you'd like to learn? 92% of you said yes. So that's great. You're in the right place. And then I was curious because we want to know, just out of curiosity, we know that Global Hack Week is truly a global event. And so we have three different continents represented here on this stream, probably even more. But it just goes to show a testament of our global community. So thank you all for logging on, no matter where you're logging on from. And I have a plug. Don't forget to check in. Let's put that one more time in the chat. So Jayan says, what projects can we get from this? It's going to be mostly classification algorithms. So anything where you need to classify data, this will be a great workshop for that. And actually, I'm going to show some of that. But first, we have an intro to MATLAB. Okay. So the important thing to do first is create a MATLAB account. We're going to be using MATLAB through something called the MATLAB Academy. And the reason we're going to use that is because you don't need a license. Okay. So why don't you go to matlabacademy.mathworks.com and that will get us uh, up and running with no problem. I did this myself too. Just log in with my password and username, and then I'll show you all my screen. All right. So you can see there's lots of online courses. And yes, of course, I will share the link in the chat. Thank you for reminding me. JFK. So yes, matlabacademy.mathworks.com is a great place to go for this information. And we're going to focus mostly on the machine learning on-ramp activities and complete those together and add a little bit more as well. All right, so I'm just going to give a couple more minutes for you to create an account. But really, once you're done, you should see a screen similar to this one. And we'll just give it a couple more minutes. Just showing you a little bit of the functionalities here. There's some amazing courses in here. Courses on programming, which, by the way, programming is really these concepts like debugging and error handling are useful no matter what language you're learning. So if you learn these concepts in MATLAB, a lot of them are going to be helpful in any language. So that's a great resource if you have some time to go through that. And I've not even looked at these software development tools. That sounds kind of cool. Yeah, you can even learn about things like unit testing, which is such an important concept to know about. And actually, even with the fellowship, we often get a lot of applications for the fellowship, and folks who use unit testing or other software development concepts in their code, they are really ahead of the game on this stuff. So that's another great concept to learn about if you're interested. All right, so why don't we then move on? Now that we've been able to create a MATLAB account, I'm going to assume that you all were able to do that because I didn't hear any questions in the chat or anyone saying, hang on, I haven't made one yet. So we're going to work together through the MATLAB Academy. So I want to start with the on-ramp activities because these are really crucial to learning MATLAB. 90% of you said you did not ever work with MATLAB. So we're going to start there. And Natalia says, is a university account necessary or not? I don't believe you need a university account for this. Um, you should not. And if you are having trouble because you are being required a university account, let me know. Um, but it should be pretty good without that. But yeah, so why don't we go to this on-ramp activity? And I'm going to share a little bit of, yes, just select as a hobbyist, as you said, Tanmay. And Natalia, you said, I'm getting an error. We've detected suspicious behavior. Sorry to hear that. I think maybe you could try logging in from a different browser or a different. Oh, look, JFK had that issue and just refreshed. So why don't you try again? And as Sandra says, what does on-ramp mean? On-ramp is just helping us get started with the language. So actually, I'm going to go ahead and bring us here to the on-ramp, and we'll click into the first module just to click Start Module. And it'll bring you into this environment for MATLAB and teach you a little bit about MATLAB. So the first module is Enter Commands. And you'll see on the left-hand side, there are tasks that you can complete. So you'll want to follow this to get the instructions for the next task. And first one is to multiply the numbers 3 and 5 using the command 3 times 5. And if you need a hint, you can get a hint. So it says click to the right of the two arrowheads. So you just click right here and use the asterisk to multiply two numbers. So in MATLAB, asterisk is the multiplication operator. So we'll just do 3, type 3 times 5. And if we hit enter or return, it gives us the answer, 15. And it even tells us that we're correct. You could see the solution as well, which is down here. And now, task two, when you specify an output variable, MATLAB stores results in a variable named answer. So we can now assign the result of 3 times 5 to a variable named m, as shown. M equals 3 times 15. So let's type that. We type m equals 3 times 15, and we get a variable assignment. So that's how you do variable assignments in MATLAB. And the next task is equals sign. So we were talking about assignment. And so we can take any value and assign the result of a mathematical operation. So x equals 3 plus 4 would assign the result of 3 plus 4 to the variable x. So now let's try m equals n plus 1. See, we get 16. That's great. All right. And now the workspace browser, which is on the right-hand side, we haven't introduced this yet, but this is a key part of the MATLAB Studio. It tells you what variables have been created so far. So you can see we have ANS and M. ANS is the default answer variable. So if you just type in something like 1 plus 2, you'll get ANS be equal to 3. And M is the variable we just created. So now the task is to create a new variable named y that has the value of m divided by 2. So we'll type y equals m over 2 and get 8. All right. So task 5 tells us about semicolons in MATLAB. So some of you might be used to Python, some of you might be used to Java, but we're going to be using MATLAB. And in MATLAB, semicolon suppresses the output of your command. So when we type x equals 5 plus 1, the MATLAB terminal displays x equals 6. But if you add a semicolon, it will not display anything. So our task here now is to type k equals 8 minus 2 semicolon. And when we hit enter, you can see nothing outputs to the terminal, right? Okay, so you can recall previous commands by pressing the up arrow key on your keyboard. So let's press all the way up to return to m equals 3 times 5. And when we press enter, before we press enter, we can edit the command. So we'll take our cursor and type in here, and we'll say 3 times k. And remember, k, we can find out the value of k by looking at the workspace. So k is 6. So when we do 3 times 6, we should get m equals 18. And that's exactly what we get. So in task 4, we calculated the value of y using the value of m. Was y recalculated when you modified m in task 6? Well, actually, no. In line y, we still have that equal to 8. So if you click see solution, it says solution is y. All right. Value of y is unchanged because MATLAB does not rerun previous commands. So to recalculate y, you would need to repeat the command y equals m divided by 2. So if we do go all the way up in our up arrows and type y equals m divided by 2, we now get y equals 9. Okay. So this is the basic ideas behind MATLAB. And I'm going to stop and take some questions now. We have one question, Jayan, who is saying, can you say what is MATLAB used for in ML? Well, today we're going to implement a KNN algorithm, which is one of the most popular classification algorithms in machine learning. So KNN stands for K nearest neighbors algorithm. And MATLAB has a great built-in tool for this. So that's one way you can use MATLAB for machine learning. You don't have to reprogram the whole KNN algorithm on your own. Great question. And I hope, Natalia, were you able to get um, your account? Please let me know if that worked. All right, so while I'm waiting to hear back, I'm going to continue on with our on-ramp because we want to finish our on-ramp. And we're already 20% complete, so that's great. Let's talk now about name variables. So we can create a variable named a with the value -2 by typing a equals -2. And remember, our task says you can name your MATLAB variable anything you'd like as long as they start with a letter and contain only letters, numbers, and underscores. So all variables need to start with a letter. Okay. And so we can see on our workspace, we actually have another variable already defined called little a, which is equal to 8. And so the next task is to calculate a plus capital A divided by 2 and store the result in a variable named mean AA. So to do that, let's first type mean AA to define our variable equals a plus a in parentheses divided by 2. And we get a mean AA is 3. And this brings up a point which I want to note, which is that most MATLAB code is camel cased. So you will typically see variables like this, but you could also code up in underscores, as they mentioned in task one. Underscores are totally valid for a variable. So however you'd like to do it is totally fine. All right. So let's go on to further practice. If you use an invalid variable name, MATLAB displays an error message and a suggested correction. You can use the suggested correction, modify it, or even press escape to delete it. So let's try to make a variable that does not start with a letter, like 3sq equals 9. See what happens. All right, so we get a invalid expression. And actually, I don't think we got a suggested correction this time. So maybe we should just hit escape. All right, maybe we'll leave that one, but if we type sq3 equals 9, it would actually give that, right? So we actually get that to work and assign to the table. All right, so click up here to next. And this task is save and load variables. So we can actually save variables in our workspace to an MAT file, which is a very specific MATLAB data file. So if you see a file name .mat, you know that person is working with MATLAB. And so let's use the save command to save all the variables in this workspace. We have a data table with 7 by 4 data set. Here it is. You can double click on it and see. So we want to save all these variables to a MAT file. So to do that, we can just type save datafile.mat and hit enter. And now we have a variable in the workspace saved as datafile.mat. And we can safely clear our workspace by using the command clear. And you'll notice that the data table on the right will disappear. And now we can reload in our data file. So we type load datafile.mat and our variables come back. right? So notice that the variable data is listed in the workspace browser, so you can see the contents of any variable by entering the name of the variable in the command window. For example, if we type display the contents of the variable data, if we type data, look at that, we get all those variable values that we loaded in from our MAT file. And if you want to clean up this command window, which look, we've got all these commands and they're all crowding us out on the screen, we could just use the CLC command and it totally clears that away. So for further practice, we can actually know that you could save only some of your variables if you want to. So you would just say load my data k. That would only load the variable k if it exists. So there it is, only loaded k. And then we can do the same by saving just k. We could save that in some new MAT file. All right. So we'll go to the next section now, which is built-in functions and constants. And before we do, I want to just check the chat. So it looks like Natalia got her count working. And thank you for checking on that. I'm glad you got it working. Please try to go to the on-ramp account. I'll put the link again just so that everybody has that. The link to exactly where we are now. And we'll all keep going together. And we're about halfway done, so we are moving along nicely. And once we're finished with our MATLAB refresher, we'll get to the actual machine learning implementation in the second half of this workshop. So just hang on tight while we go through some MATLAB basics. So the next thing we'll do is use built-in functions and constants. So you could type pi to represent the irrational number pi. So let's first create a variable named x with a value of pi over 2. And we can do that by typing x equals pi divided by 2. Really simple. And hit space to continue. So MATLAB contains a wide variety of built-in functions, such as ABS for absolute value and EIG for eigenvalues. So for example, if we wanted to say calculate the sign of x using the SIN function and assign the result to a variable y, we could just type y equals SIN x. And this is really different than Python or some other languages, because in those languages, you might need to import some library like NumPy to have sign or eigenvalue. But for MATLAB, they're already there. So you just type enter and it works. And now we are asked to calculate the square root of -9 by using the sqrt function and assign that result to the variable z. So we just type z equals sqrt, and then we put the argument -9 in the parentheses. And you can see a lot of you might have known this already, but just to reemphasize, -9 is the square root of that is not a real number, it is an imaginary number. So that's why we have 3i here in our answer. And for further practice, note that the solution contains the imaginary number I, as we talked about. And the solution only contains the first 4 decimal places. You could control the displayed precision with the format function. So if you want to display more decimals, you can actually use the long format. So format long x shows a, oh, let's try format long and then x. Now you see a very long decimal, and z would probably also give us that very long decimal. And if we switch back to format short, we now get these very short decimals, only 4. Okay. So I'm not going to go through the desktop editor because actually we don't have access to that with our Academy accounts. So let's just go to the next section here. We're going to skip this whole section here. Actually, I think we do have access to this fake version of it. So why don't we not skip the section? We'll go through this a little bit. So you can enter commands in a script by clicking the gray code box, which is right over here. And when you're ready, submit your code by clicking the blue submit button. So let's type R equals 3. We click submit. It will run our code for us and show the result in the right-hand side, R equals 3. And you can add the command x equals pi times r squared. So when we run it, we get 28.2743. And during this course, as you complete tasks in the live editor, the command window and workspace browser are minimized. So you can still access them by clicking their names, and try viewing the variables x and r in the workspace browser by clicking workspace on the right. So you just click the workspace variables pop right up. And to run scripts, you can do that pretty simply. So you can test it by running the script with a run green arrow, and it will just run the script for you as a test. So we run the script to populate the output pane, and then let's modify so that R has a value of 0.5, and we'll run again to see what the new result is. You can see we actually get a change. All right. And to execute the code for just one section, we will click the Run Section button. So let's say we only want to execute the calculate area function. Like say we change this. Oh, actually they suggest that we add a new section. So let's do that instead. So you'll use the section break button, which is up here, to make a new section, and then we will insert the text calculate circumference. And then we'll include the code y equals 2 times pi times r, which is the equation for the circumference of a circle. So if we only run this section, we get our nice pi. All right. So next, we'll talk a little bit about debugging MATLAB code. So you might find some errors in your scripts while we're doing this machine learning practice. And if you do, they'll appear in this right-hand panel. So it'll say error found, click to open. So we can do that. You see, debugging MATLAB code.mlx, which is our file, right? That's open. Value assigned to variable might be unused. Parse error at asterisk. Usage might be invalid MATLAB syntax. Ah, yeah, look at this. There's actually 2 asterisks here. So let's remove the error. We can delete that. And if we run again, look at that. We get correct answer. No more error in the right-hand margin. Now that we fixed the errors, our code does run, but there's still a warning. And so if we click on the warning, it means there's something we could improve. So value assigned to variable might be unused. And it's true, we don't use this r equals 3. So we could just delete that actually, and our code will still run. And now our warning is gone too. So that's great. All right, so now let's talk a little bit about vectors and matrices. This is a super important topic for machine learning, but let's go ahead and talk about it. And JFK says, is this somewhat like a MATLAB shell? Will we be working in a MATLAB IDE later? Yes, so actually this is a MATLAB IDE because it can interpret code. It's a little bit limited because it's MATLAB Academy, so you can't do everything that you would want to do for your own project. But it's a great way to learn some MATLAB skills and some machine learning skills so that if you ever need to use MATLAB for machine learning purposes, you have that ability. Great question. Let's manually enter some arrays. So first, a single number is a scalar in MATLAB and in math in general, and you can represent that with a one by one array. So if we just create x equals 4, that's technically a one by one array, okay? And you can create arrays with multiple elements too, so you'll use hard brackets to do that. So if we use type x equals and then 3 space 5, that is a two element, one dimensional of what array? Oh, actually, we're supposed to create one with y equals 7 and 9. Sorry, I didn't read the task. That should work then. Okay. And when you separate numbers by using spaces as shown in the previous task, MATLAB will combine the numbers into a row vector, which is an array with one row and multiple columns. And when you separate them by a semicolon, it will create a column vector. So you see in this right-hand output panel, we have a 1 by 2 matrix, which shows one row and two columns, 7, 9. But if we type x equals 1 semicolon 3, and we run this, or let's actually follow the task, create an array named z with two elements, 7 and 9, in a single column. Oops, did a little error there. Should run now. Now you see we have 2 by 1. Okay, so that's the difference. And so now in task 4, we'll create a row vector named A, which contains the values 3, 10, and 5 in that order. And we get it, 1 by 3. And let's now create a column vector named B, which contains the values 8, 2, and -4 in that order. And when we submit, we get that. Okay. You can use a combination of spaces and semicolons to create a matrix, which is an array with multiple rows and columns. So basically, we're going to combine these two techniques. So let's create a matrix named C with these values, 5, 6, 7 row and 8, 9, 10 row. So we would want to put in the first column 3, 4, and 5 in first, second, and third column. And then we'll put 6, 7, 8. Oh, sorry, actually, we want to do it in a different way because that's not the task. So we want to do 5, 6, 7, and then 8, 9, 10. Okay, so first row, 5, 6, 7, second row, 8, 9, 10. Simple enough. And now our last task in this chapter is to create a row vector named D, which contains as the first element square root of 10 and pi squared as the second element. That's kind of a fun one. And indeed, it works out great. So for further practice, arrays are a common data structure in MATLAB. And as I mentioned, we have a lot of matrices in machine learning. So it's really good to know this concept. And MATLAB is actually an abbreviation. I didn't know this before the workshop, but Matrix Laboratory. Pretty cool, right? And you can do a lot of MATLAB functionality on multiple values at once. So for example, MATLAB allows all these different ways to create an array. And if we want, we could try some different ways to create this matrix. I won't do that now, but just for the sake of time, but feel free to do it on your own. Okay, now let's create some evenly spaced vectors. So it's common to create vectors using evenly spaced numbers. So you could just type manually 1, 2, and 3 to fulfill this row vector named x. But actually, for long vectors, entering individual numbers is pretty unpractical. So we have a shorthand we can use, colon, to do that ourselves. So we type y equals 5 colon 8, and we get every number from 5 through 8. So the task actually is to create a row vector y with integer values from 1 to 10. So we just type 1 to 10. That's even harder, actually. And there you go. We get them all. The colon operator uses default spacing of 1, as you can see from the outputs on the right. But if you wanted to change the spacing between these numbers, you could easily do that by having a second colon and putting it in the middle. So let's create a row vector named z that starts with 1, ends at 5. So first we type z, 1, 5. And each element is separated by half. So we're actually going to put it 0 0.5 in the middle. And when we do that, it runs with the appropriate spacings. When we create a row vector named A that starts with 3 and ends at 13, with each element separated by 2, there we go. So if you know the number of elements you want in a vector instead of spacing them between each element, you can use the linspace function. So linspace first, last, and number of elements. And you could use commas to separate inputs in the linspace function. So for example, in here, we're saying we want 5 numbers and they should span from 0 to 1 evenly. So notice they're all a quarter apart. So let's create a row vector named b. So we start with b equals, that starts with 1 and ends at 10 and contains 5 elements. So we would just type linspace 1, 10, 5. Oops. And you see on the right-hand side, it already calculates, oh, to do this, you're going to need to increment by 2.25 each time. Yes, 2.25 each time. Both linspace and the colon operator create row vectors, but if you need a linearly spaced column vector, you can use the apostrophe operator, which will convert any row vector to a column vector. It's called transposing a matrix. So let's transpose B from a row vector to a column vector using the transpose operator. To do that, we just type B apostrophe. And there we go. Oh, looks like I should have maybe, let's look at the solution here. Maybe I did this a little bit wrong. Oh, I should redefine B. That's right. And then it'll work out. Yeah. And so creating a column vector in a single command, you could just combine everything. So let's do x equals, or we want to do c equals something that starts at 5, ends at 9, and is spaced by 2. But we want it to be a column vector. So we're going to apply the apostrophe to the entire vector and use parentheses to do that. And when we submit, it should give us the right answer. Great. And for further practice, if you wanted to create evenly spaced vectors from 1 to 2 pi with 100 elements, would you use linspace or colon? I'll let you all think about that for a minute. Anybody know what might be the best strategy here? So if you want to create evenly spaced vectors, you'll use, and you know exactly how many elements you want, you'll use linspace. Because you could type linspace 1, 2 pi, 2 times pi, and 100. And when you run the code, look at that. You'll get a 1 by 100 matrix. All these values from 1, sorry, to 6.128, which is 2 pi. There it is, 6.28. So there you go. We could create arrays with functions too. So if we create a variable named x that is a 5 by 5 matrix of random numbers, we can just type rand 5 to do that. And you can create a column vector that contains 5 rows and one column by using the rand function, 2. So we type y equals rand 5 comma 1, and it will set that matrix to be a very specific shape of random numbers. Most array creation functions accept the same inputs as rand. So for example, if we wanted to actually get ones or zeros, instead we could type z equals zeros 6 comma 3, and we'll get a new matrix with a bunch of zeros in it. And to determine the size of an existing matrix, you can use size. So let's type rand size x. Um, Actually, this will create a matrix with the same size as an existing matrix, which is 5 by 5. So let's test it. Yeah, there we go, 5 by 5, just as promised. So we'll skip the video. I don't like doing the videos too much, but we're going to do now index into arrays. So you can extract values from an array using row column indexing. So if you want to find a specific value, like the fifth row and the seventh column, you could use a parenthesis 5 comma 7. So we'll create a variable x, which contains the value 6 row and third column of the matrix data. So we'll type data, which is our matrix. You can see it on the right-hand side, our panel that we loaded. And then 6 comma 3. That'll retrieve that value. We expect it to be 1, 2, 3, 4, 5, 6, 1, 2, 3, 9.06. And in fact, it is. And you can use the MATLAB keyword end as either a row or column index to reference the last element. So let's say we wanted to extract the value in the last row and the third column of the data matrix by using the end keyword. So we want to just use y equals data. We know it's the third column, but it's the last row. So let's just type end, comma, 3. Perfect. And you can use arithmetic with the keyword end. So for example, we could just type y equals data end minus 1, which is the second to last row, and n minus 2, which is the third to last column. But we want to, in this task, create a variable z that contains the value in the second to last row, which is n minus 1, and the third column of data. So just 3. Perfect. And we'll skip the further practice here, but you could just continue to use this by extracting using the one index. So if you want to extract multiple elements, you can, this is actually really important. You can use the colon operator. So the colon operator specifies that you want all the elements in a particular dimension. For example, this code creates a column vector containing all the elements from the first column of A. So if you type data equals A colon comma 1, it'll get every row, every value in the first row, essentially. We want to now create a column vector named density. So we'll type density equals all the elements from the second column of the matrix named data. So we're going to type data, and to get all the elements of the second column, we'll type colon, comma, 2. And you can use the colon operator to specify a range. So for example, if we did volumes equals, we could do the last 2 columns of data. So the size of data, it's a 7 by 4 matrix, so there's 4 columns. So if we just said, hey, data, we want you to get that the columns 3 and 4, we would just type colon, comma, 3 colon 4. And it gets the last 2 columns. And to get the index into a vector, you could use a single index value. So if we wanted to create a variable named p that contains the sixth element of the density vector, which is this 7 by 1 column vector, we would just type density, parentheses 6. And we expect that to be 6.11, and it is. And you can use a single range of index values to reference multiple vector elements. So for example, check out this vector, Q equals density 2 colon 5. That's values 2 through 5. Okay. And we'll leave the further practice for later. To change values in arrays, you could use the colon operator. So create a vector named v2, which is only the last column of data, which is going to be colon, comma 2. Oh, looks like I didn't do that one right. I think you're supposed to put maybe 2 here and colon here, because it would be the second column and all the values there. Let's see the solution. Maybe I mixed this up a little bit. Oh, they wanted you to just type end instead of 2. That's totally fine. Although I would argue that my solution is also appropriate. Oh, when I was using hard braces instead of soft braces. That was part of it too. Okay, so you can change the elements in a vector by combining index with assignment. So we can change the second element of A, some matrix A, some vector A to 11 by just assigning that. So let's change the first element of V2, which would be V2 parenthesis 1 to 0.5. And when we do that, you can see the first element's been replaced with 0.5. And you can use indexing to change the elements in a matrix as well. So here's the elements in a matrix data. And if you just change the element of the first row, which would be 1, and the last column, which would be end, to 0.5, that should work. And again, I'm just skipping the further practices for time, but if you're watching this recorded, please feel free to do the further exercises. And MATLAB is designed to work naturally with arrays, so you could add a scalar value to all the elements of the array. So for example, we could add 1 to each element of V1 and store the variable r. So r equals V1 plus 1, and there you go. It works. You could also add any two arrays that are the same size. So for example, we could get a vector vs that is v1 plus v2, and it works because both v1 and v2 are column vectors of length 7. Okay, and you can multiply and divide all the elements of an array by some scalar. So we could do VA equals VS divided by 2, for example. We can apply statistical functions like max. So we could create VM, which is the max of VA. And we can do square root and other functions, for example, round. So we'll do VR, which is going to be the round of VA. And finally, multiply. This is a really big one. So a lot of people think this might do some kind of element-wise multiplication. For example, they might try this code here, z equals 3, 4 times 1020, and think that it would give 30 times 30, 80. But in reality, it's matrix multiplication. So you want to uh, be aware of that. And if you use the dot asterisk, that will actually do what we were talking about, 30, 80. So let's create a variable mass, which will be the element-wise product of density, and then we do dot times VA, and there you go. We can request multiple outputs in function calls. So if you apply the size function to a vector or matrix to produce single output variable, you can just do size. So create a variable named dsize, which is just size of data, and it tells us how big is that matrix. And then we have two output variables from the same size function. So you could say x row, comma, x col equals size x. And so we want to create the variables dr and dc. So we'll just type dr, dc, size, data. Really simple. You can find the maximum value of a vector and its corresponding index value using the max function. So we would get Vmax and I Vmax from the size of from max of V2, which is a vector here. And it'll tell us that the biggest value is in line 5, value of 10.15. That's really useful if you have a really big thing that you can't look at manually. So here's some documentation resources. If you need to use the documentation, let's check the documentation for randi to help complete this task. So we'll create a matrix called x equals randi, and we can look at the instructions in the task pane to the left and complete them. So um, let's see if we can just click on this. Here's randi. You can see there's all these different ways you could use randi, and it'll return a pseudo-random scalar integer between 1 and some max value. And you can even do an n by n matrix and things like that. So back to our example here, if we wanted to create a matrix that contains random integers in the range 1 through 20, we would use 20, and then 5 comma 7 tells us the shape of the matrix. So now we'll talk about plotting a little bit, which is important if you want to visualize your data. You could use plot xy to plot some x value and some y value. So we're going to put sample on our x value and mass1 on our y value, some data that MATLAB loaded for us. And you can see it'll generate a plot image for you. And we can mess with this plot a little bit. We can put sample and mass2, and we can use the red uh, for R for red color and star for star marker, and get some kind of styling for this. Remember to put quotes around your styling. There you go. And remember, each plot command created a separate plot, so you can plot one line on top of another if you use hold on. So you could use plot, mass sample, and mass1. You could use black KS marker, and then if we type hold on, oh, actually we want to type hold on first because we're going to put that on the red star plot. So see, now they're plotted on the same graph. And if we type hold off now, now that behavior has been switched off, so that when we plot our single vector, plot y, or plot v1, it'll plot on a new figure. So we could plot v1 with a line width of 3 using v1 comma line width equals 3. Just again, a lot of this is in the documentation, so you wouldn't necessarily need to memorize it, but we're just taking you through some of these stylings and line width and putting them together to try and get us an idea of how MATLAB works. All right. I'm going to skip a few of these plots because we're not going to get too far into it, and go to importing data as a table, which is actually really important for our machine learning applications. And so to extract data from a table, you can use the dot notation. So let's say we have a table elements. We want the density variable. We would type elements dot density, and we could assign that to a variable d. And so this we expect this density column, yeah, to go to d. And if you're working with a table, you might want to keep related data together. So instead of creating separate variables, you can append the result of a calculation to a table. So let's type density or elements dot volume one times elements dot density, element-wise multiplication, remember, and we'll make that a new variable, elements dot mass. Okay, I think maybe this needs to be put in the other order. I'm not sure why that didn't work. Oh, it's because it's not elements. I get it now. You can interact with the table by clicking on it in the output pane of a live script. So that's what we're doing over here. You could sort it if you wanted to. That's kind of cool. Sort from smallest to largest mass, I guess we're supposed to do. No problem. Oh, I guess I have to update the code somehow. Not sure how that's supposed to work, but that's all right. Sometimes you have a little mistake. And these are some relational operators now. So logical stuff. This is really important too, because sometimes you might want to mask out some data. So let's test if pi is less than 4 by using the relational operator and assign the output to a variable x. So we get the value true because it's true. 3.14 is less than 4. And you can compare an array to a single scalar. So let's try vector v1 and test which elements are less than 4. This is really important actually because we are often wanting to filter our data like I was mentioning before. So this logical array is really nice because it tells us which elements are passing the test. And so we could use that filter. So for example, create a variable z with all the elements of v1 that are less than 4. So we'll do v1 and then v1 less than 4, and it'll mask that out for us. You could use it with two different arrays. So if we create a variable a that contains the elements of sample, which correspond to v1 less than 4, we just use this syntax. And we could use logical indexing to reassign values in an array. So for example, we could modify v1 so that any value with less than 4, we just set that equal to 0. And now you can see 0 has replaced those values. So maybe you have some bad data in your data set and you know that all these negative numbers are bad data. You could just say anything less than 0, just make it nan. And there you go. Okay. So now we're going to talk a little bit about decision branching. So this is conditional stuff. You might have faced this in some other programming language, but the body of an if block executes only if the condition is true. So you could modify the script so that plotting the code on lines 5 through 8 only occurs if do plot is equal to 1. So let's type if do plot equals 1. Then we want to put all of this in a tab. Just highlighted that and press tab. And now we type end. And so there's actually one thing I forgot to mention. You need double equals to compare. Otherwise, it'll think we want to assign do plot to the value of 1. And you can modify the script to execute some other code if the condition is not met. So we could actually type in before end, we could type else, and then we could type this whole display command. So maybe it'll display something if we don't get that. So let's try executing our code. Actually, let's skip the further practice and go to for loops. So for for loops, we are actually going to execute the same thing multiple times. So when you run this code, the loop body will execute over and over again. So we're going to wrap lines 4 through 5 in a for loop so that the code executes 10 times. So we'll do C equals 1 colon 10. Remember, that gives us a list of 10 integers, so it'll have to go through every single one. And then we put the body by highlighting and clicking tab, and then we put n. And we're supposed to actually name our loop counter IDX, so let's do that. And we could just print that out, I guess, if we wanted to, but it's actually not telling us to print out, so I think it'll just work. Awesome. So we'll skip this project because it'll be kind of a lot to do, and we're going to move on to our machine learning project. But yeah, we'll just click the exit course button now and skip this project. But hopefully that gave you a little bit of a idea of MATLAB. And we're going to take a 5-minute break, and then we're going to learn a little bit more about MATLAB through machine learning. And I'm going to answer this question. Thank you, everybody who got my question. Sorry, I guess I didn't see this, but you all said linspace, which was the right answer. So good job. And then JFK says, could we use end to extract the last two columns? Definitely. You would use end and then n minus 1. So that would do it. But all right, we'll take a quick 5-minute break and then we'll be back.
Oops, sorry there. I muted myself a little bit there, but it was great to go through that beginner introduction for MATLAB. And the second part of our stream starts now. So we're going to talk more about machine learning now. A quick primer on machine learning. So there's lots of hype around machine learning, but basically it's a collection of techniques for extracting information from data. For example, you could detect spam emails from email data, but we'll be learning how to do this in MATLAB. So just to tell you a little bit of the components of a machine learning pipeline, it's really important to select your data set. This is super important because you want to make sure you get the highest quality data possible. And I think Cecilia talked even more in depth about this in her section. So you want to find precise data, maybe in some cases. In other cases, data with a large coverage. You might want to use freely available data or request it from a third party. You might be concerned about the speed of how quickly you can access the data or download it and how big of its size, because that will impact your training times and your inference times for your model. Our example is data from the MATLAB Academy. And so we already looked at importing data, or no, we didn't look at importing data. So that's going to be the next topic. So we'll click into here. And I'll share my tab. It should bring us right into the course. Oh, sorry about that, everybody. I think I accidentally removed myself from the stream. But our data is what we call handwriting data. So we're going to use text files that contain data for individual handwritten letters. Each file is comma delimited and contains 4 columns. So there's a timestamp on when the point was made, the XY coordinates, which are 2 more columns, and then P, which is the pressure of the point. So it tells you how is the person drawing on the screen. So let's read this in. We're going to use the read table function. So we'll store it into a variable named letter, read table, j.txt. Oops, forgot to do equals there. I think that was the problem. And now we can visualize the letter by plotting x variable on the horizontal and y variable on the vertical. So we will type plot. Remember, we learned plot. Letter dot x and letter dot y. So there you are, RJ. It looks a little wonky though, huh? And to correct the aspect ratio, we can use axis equal command. So I'm going to use C solution because I don't remember exactly how this goes, but it's like you just type axis equal, and when you hit submit, look at that. It changed the J to a very normal looking J. And we can use the same process to import the letter data for M. So let's just copy these code lines and paste them into task 4. And we're going to use M instead of J. And there it is, our M. So the next lesson we're going to do is pre-processing. And before we get to that, I want to cover pre-processing. Yeah, so the classification workflow is present in the slide. So the first thing we do is import data and select the data set. Second thing is pre-processing data. And oh, you want the link to the slides? No problem. So I'll send that again. I sent that earlier, but I'll send it again because we did have a pretty long break. So that might be kind of buried at this point. But pre-processing is the act of massaging the data into a usable form. So it could include removing and replacing NaN values. Oh, the IDE is, the link is on slide 11. So go to slide 11 and the link is there. All right, so you could normalize or scale or transform the data, and that is the way to make it more usable for the model. So let's try that out in MATLAB Academy, and the link, this time, is on slide 13, and I'll paste it in the chat too. Make that a little easier for you all instead of having to look for it every time. So we're going to correct our distance units to normalize the pen positions, because the vertical distance corresponds to 10, while the horizontal is 15. It's kind of like a tablet that you could imagine that these people are drawing on. So we want to adjust the horizontal units to be a range of 1.5 instead of 1. So to do that, it's pretty simple. We're going to just transform our variables like we learned how to do in the first part. So multiply the values in the x variable of the table. So letter.x equals, remember we can assign variables again, and we use 1.5 to multiply letter x. Remember, we can multiply a scalar by a column vector, like we're doing here. And in task 2, we're going to shift the time variable of the table so it starts at 0 and convert the values from milliseconds to seconds so that it's more intuitive. So this is really unintuitive to start at 1.3 times 10 to the 4 and go to 1.4 times 10 to the 4. So what we'll do, I'm going to look at the solution actually because I'm not 100% sure what the minimum is. Yeah, so we'll assign letter.time equal to letter.time minus the first element, which we get from 1. We learned how to get that in our first part of the lecture. And we're going to assign now the letter.time divided by 1,000, which converts our milliseconds into seconds. So you see we get 0 to 0.6 instead of something really kooky. And for extracting features, we'll talk a little bit about feature extraction. I'm going to skip some of these quizzes that we have. Oh, no screen shared. Sorry about that. I'll make sure to share screen for features, but for that previous one, you can use the C solution to get that. But now it should be good. Feature extraction is distilling our data into a set of smaller, useful features. So for example, when you tell your friend directions, you don't tell them the GPS coordinates of every step along the way, just like you wouldn't tell data of the J handwriting. So you want to distill the information into key parts. And some techniques you could use are listed below, but we're going to go into our MATLAB code to do this ourselves. So it's lesson 4. And I'll put the code into the chat for this. But hopefully now I'm sharing my screen. Sorry about that I missed that one, everybody. But remember, we have our time data, and we'll calculate the time to write the letter M by extracting the last value of letter.time and store it in a new variable called dir. So we'll just take dir equals letter.time end. Okay. Now we have a new variable, and so we're extracting that really important feature. And we can now calculate the aspect ratio of the letter by dividing the range of values of letter.y. So that would be letter.y max minus min of letter.y. And we want to divide that by the range of letter.x. So that would be max letter.x minus min letter.x. And that's a ratio. So we now have these two values that we could use to make a prediction of what variable are we plotting. So we are going to now load in some features. We have our load features. So aspect ratio and duration are two values, and then we have the character on the last column. And so we know, for example, that the J's, like this J took 0.75 seconds to make and has an aspect ratio of 3.75, all right? So we can plot the extracted features by using the scatter function. So let's just use scatter, and we'll do features dot a ratio and features dot duration. It's actually aspect ratio now in that table that they have on the right. And you see there's this scatter plot. It's not clear whether these features are going to be good enough to distinguish between the three letters in the data set, J, M, and V. So let's use the gscatter function, which will make a grouped scatter plot for our features, and we'll put letter as the third thing, which will group, character, excuse me, which will group them all together in different colors. So you can see M is kind of concentrated in this lower region here, V is in the middle, and J is this far right-hand side, which is going to have these aspect ratios that are really long. So there you go. Next is build a model. So classification model, let's actually dive into that. What is it? It's done based on feature vectors. So let's think about a algorithm that tells you what fruit something is. It could give you features like color, size, and weight. So for example, if I told you a small blue light fruit, you would know that it's not a pear or an apple, but a blueberry. And similarly, the classification algorithm is designed to make this distinction. And we're going to implement what's called the k nearest neighbors algorithm. So you might have features on x and y axis, like in this example, this 2D example. And your task is to tell what is the green circle. Is it a blue square or a red triangle? And you're going to use a radius, like this solid black line, to tell which one it is. And you can see in that solid black line circle, there are more red triangles than blue squares. So the algorithm will assume that the green circle is a red triangle. So let's implement this in MATLAB, and we'll use the next code bit to do that. And we're going to fit a model. So our first task is to fit a CKNNN, which is the k nearest neighbors model. It's already implemented in MATLAB. We don't need to do it again. And so we're going to use a variable knn model and assign it to fit cknn. And the known classes are stored into the variable and character. So we can write those out. So we have features, the data stored in features, and the response variable is character. Right? So it already just does all this classification for us and makes these predictions. Right? So it's got these bubbles where it tells us what is J, what is V, and what is M. That's why MATLAB is great for this, because we don't need to write the KNN algorithm ourselves. And we can use the predict function to determine the predicted class of a new observation. So the task now is classify a letter with an aspect ratio of 4 and a duration of 1.2. So we'll type 4, comma, 1.2. And we'll store the predictions in a variable. Oh, sorry, I need to type the model first. KNN model, comma, and then we'll put the array of variables, and we'll store that in a variable called predicted. All right, and it tells us this is probably a V according to the algorithm. So how cool is that? We have a few outliers in our data, and so we could use we could adjust the model to make it less sensitive to individual observations by increasing the value of k, which will cause the model to use the most common class of several neighbors, which is what we were looking at in our example. So that's just something to try for the future. I think we'll skip that for now, though. All right, evaluate the model. This is another thing we can do. How good is the KNN model? You might want to know. Well, let's check our slides. I want to share with you all this concept called the confusion matrix. And the confusion matrix is a really common tool in classification projects. The idea is to type your predicted conditions, which are the things the algorithm says, and the actual conditions, which are the things the data says, on a matrix. And so when the algorithm thinks one thing and the actual condition is true too, that will give a true value. So you could have true positives, true negatives, things like that. When the algorithm and the data don't match up, that's a false value. So our confusion matrix is a great way to tell us where things are going good and where they aren't. Okay? And so we'll evaluate the model in MATLAB Academy too. Basically, the first thing we'll do is classify the letters in the table test data by using the predict function. So we'll store our predictions in predictions, and we use the function predict on the KNN model and our test data. So test data is just going to be some random data that we have, and we haven't trained the model on it. It gives us the following predictions. And the known classes for the test observations are stored in the variable character of the test data dataset. So we can use the equals equals operator to compare these and store the result in a variable called isCorrect. So we type isCorrect predictions equals equals, and then we just type test data.character. Super simple. Now we want to calculate the proportion of correct predictions. These are our trues, where the things matched up, and store the result in a variable named accuracy. So we'll use sum to determine the correct predictions, which is correct. And then we'll use the numl function to determine the total number of predictions. Divide by that. And we see our accuracy was 0.8, which is 80% accuracy. And rather than the accuracy, sometimes people use the misclassification rate. So we'll use the squiggly equals operator. I'm actually not sure how to use that. I think, okay, so we use predictions not equals test data. Oops, so we would use predictions not equals test data to get misclassify rate. It looks like I have some bug here. Always a bug with live demos. So you'll just use misclass rate, and that's going to be the sum of predictions minus equal or squiggly equals test data dot character, and we divide by numl of the predictions. So our misclass rate is 20. And so here in task 5, they're showing the confusion matrix. And so we can get the confusion matrix really easily from MATLAB. And we just type predictions and test data.character. And it'll create that confusion chart for us. Super simple. And so you can see the true classes are plotted as rows, the predicted classes are plotted as x's. Actually, I think we're supposed to switch these because right now it's plotting them backwards. But you can see we have our true values on the diagonal, and then anywhere the model messed up, which was these two cases, It tells us in this for this V, the model thought it was a J. So it's a great way to diagnose your model. And so now we're going to make a model for 13 letters, and I'm going to give you actually a little bit of time to work on this yourselves. And I'll show the link to this. And I think this is as far as we're going to get today. So just go ahead and try this out. The link's actually not in the slides, so I'm going to give it now in the comments. And I want you to try this on your own and give you about 5 minutes to do it. And then we're going to take a quiz about what we learned today. So take a minute to do that. All right, everybody. Oh, I think I did this wrong, actually. There it is. Otherwise, I'd be way too big for everybody. I hope you were able to try this on your own, and now we're going to actually go through it ourselves. So, first task is to plot the observations and features using the gscatter function. So we'll use gscatter, and we will type our features. So features is our data set, and we'll do dot aspect ratio on the horizontal axis. On the vertical axis, we aspect ratio, duration, as they ask us to, and then color coded by class, which is going to be character. So we have a lot more characters now. We have about 13, so it's going to look a little bit kooky. And yeah, look at that. That's going to be a little hard for us to figure out. But fit the model to the data, so let's do that. Remember how we do this? So we type predictions equals KNN model. Fit CKNN. And we'll set the num neighbors option equal to 5. So we can do num neighbors equals 5. I think we just get rid of these quotes. I'm not sure why they have quotes there. And so we'll fit the test data to this. Or, we'll fit the features data to this. So our response variable is going to be character. And num neighbors equals value. I think that should work. Looks like we have a little hiccup here. Okay, so I guess you type it this way, num neighbors and then 5. And I forgot to do this part where we do the predictions. So remember how we did this? So this is actually KNN model. But remember how we did the predictions? So we did predict, and then first argument is our model itself, and the second argument is the test data. So that should work. And remember, these semicolons are helping to suppress the output so that it's not going to print everything to the console. And then in task 3, we're going to create a misclassification rate. So misclass, we'll just use a variable misclass to say it's going to be the sum of predictions not equal to test data dot character divided by the length of predictions. And then our confusion chart is super simple to make. Only requires 2 things: our true labels, which will be test data dot character, and our predicted labels, which are predictions. So you see, we can tell where the model's messing up. It's messing up all over the place. So a model with only 2 features where we are having 3 particular letters to distinguish does not generalize well to many letters. So yeah, we have kind of a situation now where we have a bit of a mess on our hands. So if you want to learn more about classification, I think we're going to unfortunately have to cut it here because we're running low on time. But I did want to give a wrap-up quiz. And so let me paste that in the chat. It's actually on the last slide. And I wanted it to just, and actually I think I forgot to update the name because I've changed this since we did our February version. Let me clear the old responses. I'll keep them, why not? And so I want to see what you all have learned during this workshop. So please submit the form if you can. And yeah, just tell us, what did you learn during this workshop on classification? All right, so we'll share the tab. And we had folks say they learned K&N model, K&N algorithms, finding accuracy scores, some feature selection, pre-processing, and that data has to be trained efficiently. And there can be ML models that provide answers, but if it's not trained, it gives the wrong answers. So exactly, it needs to be trained efficiently, and you need to keep in mind that if you build a model that is simple, it will not always generalize to a case that is more complicated. So that is a really important lesson from today. But yeah, thank you so much, everybody, for participating today, for coming to the workshop. There's so much more content that we didn't get to go through, unfortunately. But you can go through it on your own. This resource will be available to you. So just go ahead and use the slides to your heart's content and use MATLAB Academy as much as you can. So one more time with the check-in link, and we'll call it there. Thanks, everybody.